the rational roots theorem with example 3 is where we left off with. So if you remember, we are looking for p's and q's, and this is the big idea. The big idea is 3x squared minus 4x plus 1 is equal to 0. And that factors to 3x and x and minus 1 and minus 1. And so the solutions are 1/3 and 1. Now, just think about that. Are those rational or irrational? They are rational. Look at your solutions. 1/3 and 1 over 1. Where do they come from? P's divided by Q's. P is on top, Q is on bottom, right? P's are factors of 1, Q's are factors of 3. See how that works? And so this is just a very basic example to try to bring it home for you a little bit, but that's what we're trying to do. Make educated guesses for things that we don't know how to factor. And so again, this is our example right here. What degree is this polynomial? So therefore, we choose our p's and our q's. P's are factors of the last number, 1 and 3. Q's are factors of the front one, 1 and 2. So as we list our choices, we have to take each one of the p's and divide it by each one of the q's. So I have plus or minus 1, and then I'll do 3, plus or minus 3 over 1. Okay. So I took each one of my p's and I divide it by 1. Now I take each one of my p's and divide it by 2. Yeah. So I've got plus or minus 1/2 and plus or minus 3/2. Well, on the test, you're going to have to list the degree, the p's, the q's, and your choices. If you don't get all the choices listed correctly, you're not going to get credit. But this is the point where we make a choice, okay? Yeah. So, right now we've got good choices and we got bad choices, and we'll see if you can pick up on this, okay? I've got 8 total choices here, folks. I've got 8 choices for numbers to plug in. Some of those are good ideas to plug in. Some of them are bad. You tell me, what would be a bad choice? Why is 1 a bad choice? Is 3 a bad choice? Is 1/2 a bad choice? Is 3/2 a bad choice? Why is anything positive a bad choice? Because it's going to be positive. You plug in a positive number, you're going to get a positive result, aren't you? Oh, you know what I mean? Subtraction in there. So how can you plug in a positive and come out with 0? You're going to have something offset itself, right? So tomorrow we talk about making good choices for plugging in numbers and poor choices. Right now you can see, obviously, plugging in a positive value is a bad idea. So although we have 8 choices here, we've narrowed it down to 4 right away, right? I don't want to plug in 1/2 or 3/2, so we'll just start with -1. So -1 to the third is -1 times 2 is -2. -1 squared is 1 times 9 is 9. Minus 10 plus 3. What does that give you? Gives us 0. You see, -2 and -10 make -12, and +9, +3 make +12. Those cancel, gives you 0. So if -1 worked, what is the binomial that divides evenly? X plus 1. So what we are going to do is we're going to take this and divide it by x plus 1. And we divide it using synthetic division. How do I do synthetic division again? Bring down the 2. Multiply. So we didn't think by originally looking at that it factored, but it turns out it does. Factors to 2x squared plus 7x plus 3 times x plus 1. That's the way that polynomial factors. Does 2x squared plus 7x plus 3 factor? 2x plus 1, x plus 3, x plus 1. So what are my solutions? Look at that. They're all negative. Are you surprised? Because they were all positive to begin with, so you would have that negative in order to, get stuff to cancel out. Give you 0. Okay? So there you go. I'm not going to graph it right now, but you will graph these in your assignment, yes. Number 4, what's the degree? 3, what are my p's? 1, 2, and 4, what are my q's? So how many total choices will I have? 6, and then the positive and negative will make 12, right? So we'll start with, we'll pair up the p's with 1, and then we'll pair up the p's with 3. So plus minus 1, plus minus 2, plus minus 4, plus or minus 1/3, plus minus 2/3, plus minus 4/3. I have both addition and subtraction in this problem, so you know, I could try positives or negatives. What's the easiest? One's the easiest to try. What do you get? 0. So therefore, what's a factor? So we get 3x squared plus 13x plus 4 times x minus 1. That's how it factors. And does 3x squared plus 13x plus 4 factor? So our solutions are? Not too bad. What if it didn't factor? Quadratic formula, right? Remember, it says if there are rational roots. So we could have come up with, say this. Well, thank you. Hey, when's the next birthday here, huh? When? Wednesday. Ooh, all right, we're gonna have Popsicle Friday then, for you. All right, very good. Okay, you're welcome. All right, flip to your this sheet right here. You either want to turn to this, or you just want to tear it off. It's the very last sheet you have in your notes. If you want to tear it off, that's fine. If you just want to look at it, that's fine. So before we do our last problem, we're going to try to connect your learning to a bigger idea. Raise your hand if you've ever been in math class and you find yourself doing a process that the teacher has laid out, but you really don't know what you're doing. Like you're following something, but you're not really sure what you're doing. As much as possible, we as teachers, we want to eliminate that. We don't want you to be sitting there just doing something and not knowing the bigger idea. And so this is the bigger idea, okay? This is a decision tree for finding all possible roots of a polynomial. And so the root means the number of times that it crosses the x-axis and where it crosses the x-axis so that we can graph it. We've graphed all these, right? So when you find them, you first identify the number of roots. What do we look at to identify the number of roots? The degree of the polynomial. Then you ask yourself, does it factor? Is it easier to deal with a polynomial that factors or one that you have to use a rational roots theorem? Easier if it factors, right? And if it factors, you look at all the different ways at which we have factored. If you could get it to work out through factoring, factor it, for crying out loud. I don't know how many times I get to the test, I put a problem on there that factors, and people go right to the rational roots theorem because they're like, well, I thought that's what we had to do. No, it says find all solutions. If you could just factor it, go ahead. Be quick and efficient and get through it. But if it doesn't factor, then you have to use the rational roots theorem. That's when you identify factors of the constant p's and the lead coefficient q's, and we write them like that. And then we use synthetic substitution, the remainder theorem, to find out one that works. Then we divide using synthetic division. And then finally, we get to this part here where it says, is the degree of the new polynomial 2? Every one we've done so far, after we've divided it, we've come up with a degree of 2. Why? Because we've started with a third degree polynomial. Well, the one we're going to do right now is a degree of 4. So if it is degree 2, then you either factor it like we've been doing or you use the quadratic formula. But if it is not degree 2, then you start over. And you start with factoring. Does it factor? If it doesn't, then move through the rational roots theorem. But this is the idea that we're using the bigger picture and the connectivity to what's going on. And the other side of it is then being able to say, oh, I know the other side and how to graph them now. Not only do I understand what it means to find the solutions, I can also make a picture of them. So let's go ahead and do the last example, and then you can have your assignment. Last example, as we said, is a quartic, x to the 4th. So we start by identifying the degree. For the fundamental theorem of algebra does state that the degree tells us the number of solutions. P's and Q's. Let's do the Q's first. 1. The P's, 1. Very good. Lots of factors of 48, right? Good thing I didn't choose like 196. There's a lot of those. Or 192, I think. No. So, choices, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 16, plus or minus 24, plus or minus 48. Now, again, people ask, well, how do you know that those are the factors? That's through years of practice of multiplication and division. So if you miss one, there's no way of knowing it. It's something you have to develop a skill over time. It's kind of like being able to look at something and say, does it factor or not? It's a skill you develop. So I got positives and negatives. What do you want to try? Oh, you want to try 2. You don't want to do 1. I don't like 1 either because I see a negative 28, negative 48. It looks like that's really going to outweigh the rest of it, doesn't it? So I don't like 1 or negative 1. I think 2 is a good shot. Let's try 2. What's 2 to the 4th? 2 to the 3rd times 7. 2 squared is 4 times 8 is 32. Uh-oh, I got a lot of positive going on here. Minus 56 and minus 48. Oh, look at that. 56 and negative 56 go away, and 60 and 32 makes 48, and negative 48 go away. I get 0. Woohoo! So what is the factor? X minus 2. So synthetic division. Thank you for synthetic division. Makes our life so much easier. Could you imagine if we were doing long division right now? You'd be crying. So just like I showed you on the previous page, the graphic organizer, the decision tree, we get all the way to the bottom here and it says, is the degree of the new polynomial 2? No, it's 3. So then we have to start over. Does it factor? No. So we start with our P's and Q's again. Now, as you use your P's and Q's, I promise that you don't have any more choices than what's listed here, and you'll be able to get rid of some of them. So for example, like 48 and 16, those go away, right? Second of all, what do you notice about this? They're all positive, so therefore negatives would be a good choice. If 1 and -1 were not good choices up here, they're not good choices down here either. So I would propose that we might try, say, -2. If you hadn't tried -1 yet, try -1, but -2 might be a good option. So let's try -2. What's -2 to the third? -8. -2 squared is 4 times 9 is 6. Uh, -2 times 26 is -52, and plus 24. And it looks like -8, -52 make -60, and then positive 36 and positive 24 make positive 60, and those will cancel. So therefore, x plus 2 is another factor. -8, -52 make -60, and 36 and positive 24 make positive 60. So those will cancel. So we divide. And I divide my new polynomial, 1, 9, 26, 24, up, down the 1. So our final result, as we factor it, should have 4 parts to it if it's of degree 4. And does x squared plus 7x plus 12, what degree is that? 2. So we therefore use either the quadratic formula or we factor. Does it factor? Yes, to x plus 2 times x plus 3. Whoops, sorry, x plus 4 times x plus 3 times x plus 2 times x minus 2. So my solutions are could we graph it? Degree 4 finishes which direction? Up. Begins up. They're all single roots. And if you sketch a graph on your calculator, it's going to look awfully similar to that. In fact, we know what's kind of neat here is if you plug in 0, you get the y-intercept. If you plug in 0, what would you get? -48. So it crosses the y-axis down -48, kind of tells you about how low it goes. Pretty cool. You like it, don't you? I like it a lot. All right. Assignment, where'd you go? Uh-oh. Time for a website. So there's your assignment, and you have the rest of the hour to work. 1 and 2.